Good day, seniors. This video lesson is about the most basic of all integration techniques, integration by simple substitution. Now we have here our 11 integrable forms that we will use in this topic. The first seven of the forms are actually directly derived from the differentiation rules, and the last four, numbers 8 to 11, 9, 10 and 11, these forms are actually derived using this technique by substitution. As an example, let's try to derive this integrable form. Integral tan u du is ln sec u plus c. So let's integrate tangent x dx, and we'll generalize this as a rule later. Now, how do we do this by substitution? First, you represent tangent as sine over cosine. You know that tangent is sine over cosine dx. Now, we will substitute. In using the technique, you let u be a part of the integral. So in this case, let u be the denominator, cosine x. So in doing so, what is happening is that the given integral is slowly being transformed into this sine x dx, and then the denominator is now u. So going back from the substitution, du equals negative sine x dx. So you're implicitly differentiating both sides. So that's why the derivative of u is du, derivative of cos x is negative sine x, and dx. So notice that sine x dx here, sine x dx is equal to negative du. Now this now can be transformed into integral negative du over u. And you know that the negative sign can be put outside the integral. So negative du over u, which is an integrable form. That's form number 2. Integral du over u equals ln u plus c. So therefore, this is equal to negative ln u, and just substitute back your substitution u cos x. So that's negative ln cosine x. Now you may notice that the integrable form tan u du is equal to ln secant u. What we got is negative ln cosine x. So you just put that negative as a power. That's a property of logarithm. So that will be like that, ln of cosine x to the negative 1, and that's ln of 1 over cosine x. And of course, you know that 1 over cosine x is the reciprocal secant x. So therefore, the integral of tan x dx is ln secant x plus c. Now, generalizing that will be your rule. Integral tan u du is ln sec u plus c. So notice how the technique of substitution was used to derive this integrable form. Now let's have another example. Integral sine cube 2x dx. This integral will be a lot easier if what you're given is simply sine 2x dx without the power 3, without the exponent 3, because this can be easily solved by substitution by simply letting u be equal to 2x. In doing so, you have du equals 2 times dx by implicitly differentiating again your both sides of your substitution. So in doing so, your integral now is transformed into sine u because you let u as 2x, and then dx will be replaced with, just divided by 2. Know that the right side will come dx, so dx will be replaced with du over 2. Now over 2, that's the same as multiplying the whole thing by 1/2, and you can put that 1/2 outside your integral. Now this is now an integrable form. 1/2 sine u du, sine u du, that's actually your number 6. So according to the integrable form, integral of sine u du is negative cos u plus c. So this would be equal to negative of 1/2 cosine u. And just substitute back your substitution. Your u is 2x, so that's negative 1/2 cos 2x plus c. Okay, but however, that's not the problem. The problem is the integral of sine cube 2x. There's a power there, so we have to just illustrated that it would be a lot easier if the power is not there, but the power is 3. So how do we use the technique here, the technique of substitution? Of course, you have to recall your trigonometric identities in evaluating this. The first trick is to make sine cube 2x into sine squared 2x times sine 2x. Of course, sine squared times sine is sine cube. And then, knowing that sine squared from your Pythagorean identity, sine squared theta plus cosine squared theta equals 1, we can express sine squared in terms of cosine. So this would be sine squared theta equals 1 minus cos squared theta. So sine squared 2x in same manner can be expressed as 1 minus cosine squared 2x there, and then times sine 2x, which is this, and then dx. Now this can now be integrated by substitution by letting u be equal to cosine 2x. So if u is cos 2x, notice that your integral now would be transformed into this 1 minus, if u is cos 2x, then cos squared 2x must be u squared. So 1 minus u squared, and then sine 2x dx. So the problem now in this integrals, we have to replace this part here, sine 2x dx, with u. From now going back to our substitution, du is equal to the derivative of cos 2x is negative sine 2x times 2, the chain rule. So we have here, of course, dx at the end. So just rewriting this into negative 2 sine 2x dx. Now sine 2x dx can now be expressed as by dividing both sides by negative 2. This now would be, this will now cancel out. So therefore sine 2x dx is negative du over 2, or d over negative 2. Now this now would be, can now be written as 1 minus u squared du over negative 2. Now we will put that negative 1/2 outside. So this is now negative 1/2 integral of 1 minus u squared, which can now be integrated term by term using your very first integrable form. U to the n du equals u to the n plus 1 over n plus 1. Okay, now this now would be, now let's erase this part first of our substitution. Okay, now this now can be written as negative 1/2. Now the integral of 1 is of course u minus the integral of u squared. You know that 1 will be added to the power 2, that becomes 3 over 3. And then finally just put back our substitution u as cos 2x. So therefore this would be cosine 2x minus cosine cube 2x all over 3. And then you can distribute the negative sign. Sorry, this is negative 1/2 outside. You can distribute this or leave it as is. I'll accept it. So this would be plus c at the end, and this would be your integral. Okay, now of course, to learn more about this technique, you need to practice this. Remember that the goal of any technique, including this one, is to make or convert any given integral into these integrable forms, basic forms that we will be using for this topic. So, of course, my favorite part, the best way to learn is to do it yourself. I have here two integrals. I want you to use this technique and try to integrate these two given integrals, and you should arrive at these answers. So this one for practice. Good day, seniors.